Do you need a pump for your irrigation system but don't know where to start? Getting the correct size pump for your irrigation system is important for the health, performance, and longevity of both the pump and the irrigation system itself. Getting it right the first time will save you both time and money. One thing we often get asked is, can't I just get a powerful pump and be good to go? While you can and might even get good performance for a while, it's not a good idea. A pump that's too strong for the irrigation system can cause damage to the pump just as easily as one that's too weak. When selecting a pump, you want the one that falls comfortably in the middle of their performance curve. In order to size a pump, you'll need to gather some basic information about your irrigation system and the topography of the field you wish to irrigate. Some of the variables include your system's flow rate, the vertical distance between the water level and your pump inlet, and the required pressure of your irrigation system. To help with this, we have a pump sizing worksheet that not only lists what variables are needed, but explains how to gather them. And I'm also going to cover each one step by step today. If you'd like to follow along with me, you can click the link in the top right or in the description below to get your own copy of the pump sizing worksheet. The purpose of the pump sizing sheet is to help you narrow things down so you can use the pump curve chart to locate your pump. The two numbers you're primarily concerned with in this case is the gallons per minute, which is simply the sum of all emitters operating at one time on your system, and the total dynamic head. The total dynamic head will be calculated using the 4 variables that we ask for on the worksheet. I'll show you how to get those. To guide you through the worksheet, we're going to size a pump for a sample system. It's one we see a lot, row crops being irrigated by 5/8 drip tape. The first entry on the pump sizing worksheet is total gallons per minute. This is the sum of all emitters you have or will have that are operating at one time. If this is for a multi-zone system, you'll still want to determine the flow rate of all zones, as it's important to know the zone with the highest flow rate and the one with the lowest flow rate. Though pumps are sized for the highest flow rate zone, there are some special considerations to take into account for your lower flow rate zones. That's something we'll cover later on in the video. The system we're sizing for today is a single zone that consists of 44 120-foot rows. We'll be using drip tape with 0.25 gallon per hour emitters spaced every 12 inches. Since the tape specifications are gallons per hour, but we're going to be working with gallons per minute, we'll just have to do a simple little conversion. At 5,280 feet of drip tape with a 0.25 gallon per hour emitter spaced every 12 inches, all we have to do is multiply the length of the tape by the emitter flow rate. This will get us our entire system flow rate. In this case, that's 5,280 multiplied by 0.25 for a total flow rate of 1,320 gallons per hour. We'll divide that by 60 to convert it, and we'll get 22 gallons per minute. All right, now we can put that on the first entry on our worksheet. Now we need to determine the vertical distance between the water level and the pump inlet. For the sample system, let's say we're going to be putting our pump in a pump house that's about 7 feet above the reservoir. All we need to do, then, is put 7 feet on our suction lift entry. Note, if you're using a submersible pump, the suction lift will always be 0. This is because the submersible pump is typically submerged in the water. Thus, there will be no distance between the water level and the pump inlet. Okay, now that we've determined our suction lift, let's move on to elevation change. Now we need to know the vertical distance between our pump inlet and the highest point in our system. If the pump has to pump to a higher elevation, you're going to have to calculate the vertical distance between the pump and the highest point in the field. There are multiple ways you can do this. There are free mobile apps, land surveys, or you can even measure your static pressure by filling a tube or pipe at the highest point, measuring the static pressure at the bottom, and then multiplying by 2.31 to convert it into feet. There are a couple other methods you can use to easily calculate your elevation difference. We've included a link to an article in the description below that'll walk you through step by step of some of the methods. In our sample system, we have a lot of rolling hills, so we're going to have the highest point be 38 feet above our pump inlet. This distance may allow for us to use a smaller pump, as the gravity will be doing a lot of the work to generate water pressure for us. We can record 38 feet on our worksheet. Now that we got our elevation change, it's time to move on to our friction loss in feet. This next part is a bit more challenging. The passage of water through pipe or tubing causes friction. This friction reduces pressure. In the industry, we call this friction loss. There are quite a few factors that go into friction loss, from the viscosity of the fluid to the material the pipe or tubing is made of, to filtration and to fittings. But we're primarily concerned about the length of the line the water will be passing through, its diameter, and the flow rate going through it. With this information, we can quickly determine our friction loss and then convert it into feet of head. Now, we know our flow rate is 22 gallons per minute. Though we haven't chosen a main line yet, we can use that flow rate to help determine what size and diameter would work best for us by calculating the friction loss. Too much friction loss, and we'd either have poor performance from too low of pressure, or we need to spend much more than we might need to on a stronger pump to be able to push the water through the piping. Calculating friction loss isn't nearly as daunting as it sounds. There are online calculators you can find that will automate most of the process if you know a few variables, but even without calculators, it's surprisingly not too difficult. If you know the material of the line, its total length, the flow rate going through it, and its internal diameter, you can determine the friction loss for your own application. We use manufacturers' friction loss charts to aid us in this. Manufacturers' charts have friction loss tables for many different material and pipe and tubing types. We've linked these and several other resources, such as calculators, below. Keep in mind, every manufacturer is a little bit different. So, depending on where you get your pipe or tubing or hose, be sure to check the manufacturer's friction loss charts when you're performing this step. First, locate your material type in the charts. Common materials are PVC, lay flat, or polytubing. We're going to be using lay flat hose, so we're going to reference the charts for that specific line of lay flat. Once you're on the correct material type, locate your flow rate in gallons per minute on the first column, then your hose or pipe diameter in subsequent columns. Once you have both, you can see how much PSI will be lost per 100 foot of material. As you can see, the chart is in increments of 5, so our 22 gallons per minute isn't directly represented on it. Now the chart isn't exactly linear, but we know we're going to be a little bit higher than 20 gallons per minute and a bit lower than 25. It's not exactly splitting the difference since the chart isn't linear, but I'm going to go with 1.54 PSI per 100 feet. Since I have 200 feet of lay flat, all I have to do is add 1.54 twice to get my total friction loss. These charts can also be a handy way to size your main line. If you'd like to learn more about sizing your main line, check out our video there in the top right. 200 feet of 1 1/2 inch lay flat with 22 gallons per minute going through it will lose about 1.54 PSI from friction for every 100 feet of the lay flat. This means our total friction loss for the 200 feet of lay flat is about 3.08 PSI. To that, we're going to add up the 5.1148 PSI we lose going through the filter. You can typically find the pressure loss of your filter on your filter specification sheet. Now you'll recall, I also mentioned that fittings cause friction losses. They cause very small friction losses. So I'm just going to add one more PSI to account for the fittings. In our case, it will just be a T and an elbow. This gives us a grand total of 9.1948 PSI in losses. To convert these losses into head of feet, all we need to do is multiply by 2.31. This gives us a total of 21.239988. And we're simply going to round that up to 21.24 and put it on our worksheet. Let's take a look at the next entry on our worksheet, required PSI. Required PSI is basically how many pounds of pressure the emitters on your system need to operate optimally. This can vary quite a bit depending on the emitters used. For example, from 10 to 15 PSI for drip tape to 40 to 50 PSI for lawn sprinkler rotors that we'll show later on in the video. Identify the emitters you have and their optimal operating pressure, or at least the pressure that you'd like them to operate at, as the pressure changes the generated flow and throw distance, so you can match the pressure to what you need on the specifications of the emitters. Our system is going to use 15 mil thick drip tape, so our required PSI is 15 pounds. And that's basically it. Now, all we have to do is multiply that by 2.31, just like we did the previous entry, to get our answer. Now we have almost everything needed to size our pump. All that's left is to add up all the previous entries so we can record what's known as our total dynamic head. Total dynamic head is simply the sum of all previous entries, except for gallons per minute. That gives us a total dynamic head of 100.89. With our gallons per minute and our total dynamic head, we are now able to locate a pump on the pump curve chart. When selecting a pump from the curve chart, it's best to pick one that's nearest but just above your total dynamic head. This ensures that the pump is adequate for your needs, even if it's closer than the next one above it. This means we're going to select the LP100B, a 1 horsepower pump with a 1.5 inch outlet. Though our sample system here is only a single zone, you might be wondering what to do in cases of multiple zones. When sizing a pump for multiple zones, you have to size for your largest zone, or the one with the highest flow rate. For example, if we had a second zone on this system that flowed at 10 gallons per minute, we'd still size the pump for our 22 gallon per minute zone to ensure that the pump could handle the flow rate of that zone. This, of course, goes back to my warning near the start of the video. A pump that's too powerful for a system poses a danger to the longevity of the pump. This still holds true. So, what has to be done in these cases is what's known as a bypass. What you do is create an extra section of piping that tees off the line for the smaller zone. This section of piping, in turn, will lead back to the water source. This way, the excess water is simply returned to the water source, allowing the pump to operate in its optimal zone without wasting water. Oftentimes, a ball valve will be installed on the bypass so that the flow of water can be decreased if need be. You now have the knowledge you need to get started in sizing your own pump, so you can ensure you get one that is a good match to your application's needs. Matching the pump to the system will save you both time and money. If you're ready to jump in and get started, you can find the link to our pump sizing worksheet right here. In addition to the worksheet itself, we've included some other resources, such as friction loss charts for various material types, links to friction loss calculators, the pump curve sheet, and links directly to some of the pumps. Now, if you go through the information and you're still not entirely sure what pump is right for you, please don't hesitate to reach out to us in the comments below. We read and reply to every message you receive. If you like, you can also reach out to us on our website, dripdepot.com.